Ladies and gentlemen, hello and welcome back once again to the longest running show in the world about data. It's called DM Radio, rocking year 17 here, folks. We're very excited to have one of my best friends in the business, one of the brightest minds I've met on the call today. There he is, Sean Michael Brehm of CrowdPoint Technologies and the Node Nexus Network. And by the way, he's also now the chief executive of Spectral Capital. So this guy wears a few hats out there. Luckily, all of these interests align. So CrowdPoint, Node Nexus Network, Spectral Capital, and Spectral in particular, it's a publicly traded company. It is focused on building a quantum bridge. I first heard this concept, I thought that makes a lot of sense because quantum is here, first of all, just to let you all know. There's been a lot of hype about this for a while. It is here, it is happening, but there is a tremendous, what they call in the business, impedance mismatch between the engine of quantum and basically everything else on the systems and applications side. And that is the chasm we have to get through here. And there are also financial chasms, there are organizational chasms, there are lots of different things that are in between the real world in which we all interact these days and the power of quantum computing. And I don't think there's a person on the planet who's better equipped to explain to us what all that means than Mr. Sean Brehm. So, Sean, that's just my opening salvo here about where we stand. There is this tremendous power that some people are using today, but it's a very limited group. It's an elite group, I guess you'd say. And what you're trying to do is build a bridge which involves protocol, it involves algorithms that are quantum friendly. It involves basically building this bridge that will be able to connect that engine to our everyday lives. If you would just start us off on where we are now and what you think about all that.
Yeah, I think I could have said it better. I mean, at the end of the day, we know that the concepts of quantum computing and the kind of power that will provide us are going to have tremendous impact on us. It's going to impact security. It's going to impact what we think is artificial intelligence today. It's got such amazing potential, but in many ways, quantum computing is seen by many as being, not possible, too far out there, and you've got a lot of people, in the early stages. It's like the Oklahoma land rush. Everybody's kind of rushing out there. Some have got the right idea and they're moving towards, beyond Oklahoma and looking at the Rocky Mountains and then the Navaseradas and coming into San Francisco with the Pacific Ocean. They can see that far, but there's a lot of noise as in this initial starting gun on quantum computing. And I think the biggest thing that people need to understand about quantum computing, it is here. The question is, you just can't run towards it. You kind of come up with a crawl, walk, run methodology. And so what we've been working at Spectral is to kind of create this quantum bridge. And part of that quantum bridge mechanism is the company is a publicly traded company that is a quantum incubator. So what
Hmm.
that means is our job is to go out and find the pieces and parts of how we can take a look at existing technologies that are out there, ones that are a little bit ahead, and figure out how we can start creating that bridge between what we're seeing and many people would call the current web technologies or the current Internet of Things or the current analytic approaches and bridge them to quantum computing. And for us, you're the data guy. It's been about data since day one.
Hmm. And there's this concept too, and I love this concept. It's a real world thing, a flywheel. A flywheel comes in very handy for a car because it captures energy in the middle and it sort of attenuates and allows everything on either side to work. And that's kind of what you're trying to build here, right? Is a flywheel slash bridge in between this tremendous power of quantum computing and all the applications and systems and things that we do in the real world. Is that a fair assessment?
Yeah, 100%. And then you have to figure out what's the starting point of that is. What's the initial marker of that flywheel? Where's everything lean on? And as a data guy, it's data. I mean, data, many people say is the new oil. So if you look at, the way the world works today is much like oil refineries. You take this crude out of the ground and then you got this oil and then you get petroleum engineers and you refine it, and then some is really high grade, and that goes to power, rocket ships and top secret jets, and then you've got really really crude stuff, and even down to stuff like petroleum coke that powers big, huge industrial plants, from dirty to super clean. And so what you have to look at when you get into quantum computing is quantum computing gives us the ability to exponentially refine data into information, because information is really what powers the global markets. So you've got to look at quantum computing as a mechanism by which you can more efficiently, refine this data from many different sources with the velocity, the variety, the veracity problems, variability. But the key is, how do you extract the value out of it faster and more efficiently? And that's what quantum computing, if you break it down, that's really what quantum computing is here to do.
Yeah, and just to explain to people, so traditional computing, we all understand, most people understand, is zeros and ones. It's actually, if you get right into the weeds, it's really above and below a certain threshold, and below it counts as a zero, above it counts as a one. But the point is, you got two options. And so if you look at a lot of the work that's been done over the last half century in computing, one could argue that a tremendous amount of effort has been built around trying to reconcile this binary view of the world with the non-binary, to use a weird word of the day,
It is a weird
reality
word.
around us, right? So
Yeah.
we live in an analog world. It's not a digital world. And even digital, like I'm suggesting, really is analog with a sort of superimposed structure on top of it, which is the zeros and ones.
Yeah.
But so much effort has been built around trying to reconcile the the shortcomings of binary with the analog reality around us. And of course, quantum uses qubits. And maybe you could explain that just so people understand, because a qubit is like a quantum bit, and it could be in what they call a superposition representing zero, one, or both simultaneously. And this
Right.
is what I heard from an expert I talked to a few months ago, who says it's not just four directions. I thought it was four. He's like, no, 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 no. It's any number of directions. And that is central to why it is so powerful at being able to refine the oil you're talking about. Can you just explain that?
Yeah, 100%. You nailed it. First of all, qubits, that's the building block of quantum computing, and it's capable. Really, the thing that's mind-boggling, existing in multiple states
Right.
simultaneously.
Right.
So that's kind of like, that gets into beam me up, Scotty, kind of stuff, right?
Right.
And so when you look at that versus the binary of it is or it isn't, you get into multiple states and it is, and you're looking at, concepts that are just, it can be lots of different things at the same time. And then you brought up a great word, superposition. And a superposition enables those qubits to perform many calculations at the exact same time. And then once you get beyond those two mind-boggling concepts, you have to look at the concept of entanglement. So entanglement
Hmm.
is a quantum phenomenon that where qubits become interconnected. This allows for instant information gathering. So what I would really say, it really allows for instant data surfacing, and you get into really interesting things with governance, lineage, and provenance at lightning speed. And then that gets you to a new kind of information sharing. And then when you look at quantum gates, that means that we can now have multiple and and things that can manipulate those quantum states, enabling computer computations. So data can be an information can be held in many different forms and do many different computations. And then you get into the gates themselves, the quantum gates that allow you to manipulate those qubit states, which is really interesting. So now you look at, initial analytics surfaces this summary. That summary gives you the idea to identify some kind of connectivity with another one. You can surface hard, soft, and absolute rules really, really fast. So now you can combine soft rules, and then you can quickly remove those that are soft and start moving into absolutes. So that concept, once you get into the quantum gate, means you've got to start getting into these additional concept called quantum gates.
Hmm.
And those quantum gates get you into quantum algorithms. And quantum algorithms, that's where the sauce, that's the refining of data. That's where specialized algorithms that leverage quantum mechanics that we just talked about for better problem solving. And
Hmm.
then entrance into quantum speed up, which is the ability to solve those problems faster. Then the benefit, the part I love the most is, especially a world where we're sitting at $11 trillion in cybercrime. Now you have the added component that kind of wraps around that, and that gives you quantum security, and that's this advanced encryption methods that protect data from cyber attacks. And then it gets even faster with the advent of decentralization. All of these concepts you and I have been bumping around for the past 2.5 years, and quantum computing really has kind of given us that 8 kind of step framework on how to operate within.
Yeah, and in my research too, I'm just finding all sorts of other interesting concept. There's this concept of interference, right, where different qubit states could interfere with each other either to constructively reinforce or destructively cancel out. And apparently, this allows quantum computers to amplify correct solutions and suppress incorrect ones. Can you talk about that for a second?
Yeah, so when you think about it, this really gets into some concepts you and I have talked about before, which is the concept of entropy, right?
Hmm.
If you don't know what wrong is, how do you know what right is?
Right.
And so I remember, I won't say the name of the company that's really big that a lot of people use to search. I was with some engineers one time, and we were talking about these learning dictionaries, and I said, well, what I don't understand is, they're like, you use our dictionary, do you use our libraries? I said, no, I've run some entropy on them, and I've seen some issues associated with that. And this was in Salt Lake City, and I go, entropic models, and the guy looks at me and says, well, I took like a quarter of that in college. So when you start getting into quantum computing, those concepts of entropy in real time allow you to really get into something a friend of mine said years ago when we were working together on projects inside the intelligence community. He said, look, really, really good technology gets to the point where data can find the data and the user can find the relevance. So when you start talking about the concept that we're talking about here, is it's about providing relevance, but not only relevance, but the correct relevance. And that's kind of sums up the benefit of this construct.
Yeah. And entropic models, I mean, if I understand them correctly, with these large language models were designed to open up the potential of what the answer could be because they're trying to, I suppose, reflect the creative nature of the world around us, right? Or trying not to be so precise, but in opening that gate, they also open the door to hallucinations and to other things of this nature because to your point, if there's no North Star, actually, one of my good friends from ExxonMobil had a great point. He goes, we have to stop letting these things pattern recognize their way to the truth. There,
100%.
there needs to be a truth, and then you gravitate toward that. That's what you use regression models for and things of this nature to see, okay, are we online with the truth according to the truth we know?
Yeah.
Right, but these entropic models are just pattern recognizing. So if you get enough bad data in your system, if it's trained on enough bad data, it's just going to give you really, really bad answers, right?
Yeah, well, I think there's two aspects for it. If you don't know what wrong looks like, you never know what right looks like. But your point about the North Star is really good. One of the major problems you get in these large language models is as you ask it a question and it's surfacing possible answers, it kind of hallucinates because it gets lost,
Hmm.
right? And I think your North Star is a really good analogy. Like sailors, if they get lost, they can navigate off the North Star. Like, I'm not a sailor, but as a former Army Ranger infantryman, when I got lost, I found two known points, and there was contour lines. I could see those contour lines coming more and more dense. I knew there were hilltops, so I could subtract or add 180 degrees, draw two lines, and I knew exactly where I was. In other words, I could vector where I'm at. So when you start looking at large language models, there isn't any kind of contour lines in the data or concentric rings that show you density of truth. And because you don't have
Right.
that density, you meander. So one of the cool things about kind of going away from large language models and getting into these ontologic language models that are very hard to pursue in a traditional computing environment, quantum computing now can say, hey, some of the more esoteric are like, there's like, well, it's your truth. In other words, I can create an ontology around the way I speak. So within my community, I speak tech. But if I get around a lot of my buddies from the military, we've got acronyms that we use all the time that 9 out of 10 people would understand. And then maybe if I attend a certain synagogue or church, I have another set of ontological models. So the human being is an amazing assembly of ontologies. And so what happens is when we start taking our own authentic intelligence and we start capturing it, you can now start learning, something at the label level, and you can start saying, okay, what's the distributions and frequencies? Well, how do they co-occur? And then you can start running entropic models or entropy on the data to find out, what's not right. And then you can focus on the good. And then when you start sharing that ontological language model with others, you start moving into a concept MIT talked about years ago. In fact, Dr. Cohn talked about it on a show with you in the past, which is getting us to collective intelligence. And
Hmm.
quantum computing is going to give us the compute capability to get there. And this
Yeah.
is no longer esoteric conversation and what if. It's really what now.
And this kind of gets it. That's great segue. We got our first break coming up here in just a minute and a half. But remember, folks, we have this quantum power, and it does exist right now. It can be leveraged. There are companies that can use it today. But there is this just mismatch of power. It's basically like taking a rocket engine and putting it into your Mazda Miata, right? Like you can go drive it if you want to, but you're probably going to crash. So you have to redo the wheels, you have to redo the brakes, you have to basically redo the chassis, you have to fix everything around that so that the engine just doesn't blow stuff up. And it's a very expensive engine, I might add. I mean, what's kind of fun is we're going back to the time sharing view of the mainframe. It's almost like the new mainframe is what this stuff kind of boils down to. So you'll have time sharing in these quantum environments, but you have to figure out how to build your new chassis, how to build your new brakes, how to build all these other things. And these are the component parts of the quantum bridge that Sean is talking about. And so this company, Spectral Capital, it's an incubator for quantum technologies. They're out there looking for the different component parts, the governance component, the analytical engine, all these different things need to be around this beating heart of quantum power such that we can leverage it efficiently and effectively and not blow up our traditional environments. So, with that, we're going to go on a break, folks. Don't touch that dial. You're listening to DM Radio. All right, folks, back here on DM Radio with the inimitable Sean Michael Brehm of CrowdPoint Technologies, Node Nexus Network, and now, of course, Spectral Capital. And very interesting stuff going on there. We wanted to talk about Node Nexus Network and this decentralized network. So some people are starting to wake up and figure out what all this decentralized stuff really means. And it does mean finding a path that is not so contingent upon one center to hold it up. So if you look at Amazon Web Services, you look at Microsoft Azure, you look at Google Cloud Platform, these are centralized platforms. Now they have distributed architectures underneath, but it is one company, one choke point to a certain extent through which everything goes to get stuff done. And with a decentralized network, and correct me if I'm wrong here, Sean, but you have folks all over the world now, thousands of people who are part of this network, and their computers will spin up an instance and then connect to the rest of the network. But the point is, they are individual stacks all on their own. So it is truly federated. If you think about the DARPANET, which I'm sure you or ARPANET or whatever, which was the foundation of the web, one of the key concepts was decentralization, so no one can take out the whole network with one node being taken down. That was the whole idea, is to have a resiliency in terms of information transfer. And now you're taking that concept through Node Nexus Network to build the pillars of a blockchain, but it's also marketplaces on top of that blockchain. The point being, it's truly decentralized, and thus there's no choke point. There's no one string someone can pull to take this whole gosh darn thing down, which, let's face it, whether it was intentional or accidental or whatever the hell just happened with CrowdStrike, you just saw a third roughly of the information systems in the world brought to their knees, all because a file was loaded into the BIOS of these machines, and a little driver that was already there went to read this file, but it was a nothing file. It was a do not touch me file pointed to bad memory, as I understand it. So that's just an example of the dangers of a centralized architecture, right? So tell us a bit about Node Nexus Network and how it's different and how it fits into this whole equation.
Yeah, it's, when in past shows, you and I have been talking about the concept of decentralized computing, and at CrowdPoint, we've been working on a distributed quantum ledger database, which is, exactly what it means. It's decentralized and distributed. It provides a quantum ledger, which means the data within it is quantum proof, it's quantum speed enabled, and then it's also a database. So I got on the road and started selling, and I'm over in UAE, and I found a company, a bunch of guys from Russell Hema and from Dubai, that were putting together an edge and hybrid cloud strategy. And I said, well, you need to really consider a distributed and decentralized quantum ledger database. And after walking them through the quantum ledger database, they're like, wow, this is pretty compelling. This is truly quantum ready, because you've collapsed the application layer and the data layer and the compute layer into one. And this really is going to be kind of and they actually the ones that said this is going to be a bridge to quantum computing. It's going to be the foundation. So as we started talking and selling the concept, they kept looking at me going, hey, we got a great CEO here. Can you come on board, and we're going to rename the company, and we want to create this whole other opportunity here with you. The company's called Node Nexus Network out of UAE. And the idea was take a traditional approach to edge and hybrid computing, which is got a massive total addressable market, in the trillions, and it's got a huge potential. So now what happens if you now federate those, as you said, across 16 global regions and 251 nations, where it's 5 shipping containers, 3 containing server racks in them, for about 1,500, providing about 1,504 servers, a knock, and then you got an entire 40-foot container that's filled with batteries from the hydrogen power, and then you power the whole thing with solar panels on top and wind, and now you've got the sustainable edge compute environment that also has quantum capabilities that doesn't touch the grid. So you got this really sustainable model.
Hmm.
And that's really what drove it. As I was going here, I came to Switzerland. I was talking to some guys about, doing $100 million bond to do it, to help grow this as chairman, using some relationships. And we're in Zug, and all of a sudden I meet some guys that have been looking at quantum computing, and they're like, whoa, this is really compelling. We're looking at some really interesting things, and on doing crazy things with graphene and creating graphene fields, and doing some really interesting things at the cellular structure of bacteria and graphene. And next thing they're like, hey, you got a pretty strong vision. You got a great way of, taking this quantum ledger technology and then decentralizing it and not impacting, the current infrastructure, and that's going to be needed for quantum computing. Would you mind kind of come on the board of this publicly traded company? And then, after a month or so, they said, come on board as a chairman. So essentially, our quantum bridge program is literally this. The value proposition is simple to CEOs out there. How would you like to save 40% off your current hosting? Immediately engage in an edge and hybrid cloud strategy in which all your data can be moved into a distributed and decentralized quantum ledger database, which leverages BLS 12381 and Sphinx Plus 64-bit security to literally make your data immutable. You can create these coalitions where at a snap of a flip of the wrist, you can create cross correlations with no APIs, and at the same time, it's all in a JSON format that kind of lets you build your own ontological language models. Now you can go to market with your own personalized AI. And one of the demos we showed was taking, the old a database that was very similar from an old company, very similar to Blockbuster, and started showing what happens. And you can have a conversation with a legacy database. And that's what's exploded the vision. And so what we're doing now with our Quantum Bridge program is like, look, we got a great program for you to get into quantum computing, start at a distributed quantum ledger database, put it out at the edge, leverage a solid edge hybrid solution. We've got this integration module that gets back into the centralized. So if you want to make sure you can still maintain your analytics in a centralized place, but you can save 40 to 50% off, and then migrate your company to your own version of an authentic intelligence. And when you take that authentic intelligence and you interconnect it with your supply chain or your business ecosystem, you're creating what MIT calls a collective intelligence. And that has really just has me on the road 24/7 today, with
Wow.
people responding really well.
Yeah, and you're yeah. I mean, there are lots of different aspects of this to dive into, and I did want to touch on some of the material science involved here, and you kind of hinted at some of that. In UAE, there's this project where they are using. Maybe you could explain a little bit what that's all about, because again, the wafers you have to create the new chips, for example, to
Yeah.
create next generation chips. Can you talk about the material science under that? Because that's from the UAE too, right?
Yeah, yeah. So when you look at a lot of, UAE has had always had some pretty good lineage, and I think honestly, there's some initiatives you're going to be hearing about, not announced by me, but I have insight to them. I think you're going to see a new kind of Silicon Valley emerge out of UAE.
Hmm.
And when you think about it, Taiwan is problematic. The U.S. has really moved a lot of out there, these guys are thinking beyond the current problems. I mean, you get them in a room and they're like, Sean, this is if we're going to get to quantum computing, it's a gamma light problem. And those of you that understand how chips work, patterning today of chips happens through a process called photolithography. And essentially, what you have to look as a Pentium chip or any kind of computer chip is a microtized version of of Venice. There's lots of canals. And so the problem is when you use light today to pattern that, you're at 0.35 times 10 to the negative 18. And there's no more light to pattern it even smaller. So now you've got this huge, massive problem. How do we solve patterning independent of trying to move qubits through a canal that is this wide, that needs to be the width of my finger tip, actually the nail of my fingertip. And that's one of the biggest problems. And so what they're looking at is, well, let's start using some really interesting science. Let's start creating graphene fields. Let's start looking at bacteria. Let's start looking at, splitting mitochondria. So I think what you're going to see is really low energy, super fast ability to build these new kind of chips that doesn't require a fab that cost you $1 trillion. And I think
Mhm.
that's what's really exciting about what we're starting to see in UAE.
Well, and so to kind of get back to the bridge concept here and the flywheel that I was talking about, you have all these component parts. You have the quantum power, which is tremendous, but you need to we need to be able to figure out how we're going to fuel this thing and how we're going to build the next generation of hardware. And to Sean's point, some very interesting things are happening in that space. And you do have to think way outside the box to use this. But again, where along the line are you going to be able to capture and store energy, then be able to distribute it to the rest of your architecture? Because we're talking about an information architecture. If you get right down to brass tacks, this is all about information architecture and access to appropriate data at the appropriate time to do the appropriate things, whether that's a transaction or an analysis of something. And what's cool about this quantum stuff is it can do all kind of stuff at the same time. And your quantum ledger database also has flattened the different component parts, which were artificially separated in the first place. If you think about it, like, and this gets back to my opening comment that the zeros and ones and that whole mindset about how compute needs to be architected is being challenged now, and there are different ways to do that. So you don't have to separate out the analysis. I mean, we've had this for years too. There's in database analytics, there's in database AI, there's all the kind of stuff you can do architecturally, but how efficient is it compared to what you could be doing? And that's what you're focused on with this quantum bridge, right? Is building out the component parts that will essentially become a flywheel for the power of quantum, right?
100%. I mean, if you look at the current big data models, you and I have grown up in them. You had to take data out. You had to establish this landing zone. So you had to extract the data. Then you had to transform the data into some kind of common schema. And then you had to load that data. And then you could start running analytics on it. When you start getting into the superpositioning we talked about, and the quantum, the qubits being have multiple states. Now all of a sudden you've got all these possibilities of what that data could mean in persistence. So in the end, as long as you can basically create a semi-structured model with objects and arrays, which I think every 16-year-old kid in the world can use a JSON file, and you take the data that you don't want to share and you leverage technologies that are 64-bit capable of being quantum or quantizing data. Now all of a sudden you can commingle, your first name, middle name, last name, date of birth, social security number, and quantize it along next to all the financial transactions you've made with your credit card, index those transactions against the same global industrial categorization standard that Wall Street uses. And now what you've done is it comes to the crux of the vision is you're able to return more value to everybody because the human identity, which is the life behind the oil, is operating at the intersection between commercial and capital markets, and quantum computing is going to really flip it because, as you know, right now, everyone listening to this call works in the commercial markets. They're buying handbags, they're buying a banana, they're buying ice cream, they're buying an automobile, and all of those are happening in the markets, guessing. And at the end of the day, your data is in a database, and then that's stolen by some 16-year-old kid in Moldova that does a SQL injection and sets, trillions of dollars in cybercrime. What happens when you're the custodian? You're in custodial agent of your own data. Wow, you start getting paid for being you, and you've got a much more efficient model fusing commercial and capital markets, which pays for this tech. And the value of having a quantum compute capability with all these multiple states looking at multiple individual authentic intelligences and assembling them in real time to kind of a collective intelligence. Not my idea. MIT's been saying this for years. That's when this idea of quantum computing becomes less a pie in the sky. And we're seeing it today. I can literally, we already created this whole model, and I can show you examples of, one ontological model colliding with another ontological model. You can ask it an obscure question like, who's the best president in American history? And he goes, I don't know who they are. Because in that coalition of data, it doesn't have outside ability to talk to everybody. And then you've got another coalition that maybe the history of the United States. So when you combine the two, now all of a sudden you've got this collective intelligence. No need for APIs, which are really easy to hack. Custodianship is tied to the right person, and you've got this
Mm,
really efficient model. And you're to see massive disruption in the industry. What happens to all your middleware application? What comes
mhm.
to all these RDF frameworks and all these things, these rigid concepts that we've had to follow? You get it. It's just mind-boggling. And to the average person out there, like Sean, I understand the words you're saying. What you should understand is if data is the new oil, and you've got quantum as the best refinery on the planet, you're going to get more accurate. You're going to provide new discovery, and at the end of the day, it's going to provide a great quality of life for all of us that engage in this new way of computing.
Yeah, and I guess this quantum ledger database that you folks have been working on really is the at the foundation of the flywheel in a sense, right? Because and for those who don't know, this concept of impedance mismatch, basically it means the timing of this engine does not align with the timing of the rotator. So you think about a car engine, right? You're spinning the drivetrain with these pistons, and quantum has an incredibly powerful set of pistons. They're just spinning out tremendous amounts of energy. So the flywheel is necessary to capture and to smooth out the distribution of that energy. And that at the foundational level is going to be is this quantum ledger database, which is designed to take input from this thing, manage it, persist, and then do what needs to be done on the application side over here. So, I mean, this is deep stuff, folks, but we're going to get deeper into the weeds with Sean in just a minute. Don't touch that dial. You're listening to DM Radio. All right, folks, back here on DM Radio talking to Sean Michael Brehm. He is the CEO now and chairman, I believe, of Spectral Capital. He also runs CrowdPoint Technologies and the Node Nexus Network. Luckily, there is alignment of interest in all these organizations. You've got CrowdPoint Technologies, which is focused on the crowd world, the crowd ID, the human identity as the source of all intelligence, and your data is valuable, of course. And hitherto, it's been leveraged by Facebook and LinkedIn and Instagram and Google and Microsoft and all these organizations have used your data to train algorithms and do very clever things, and then sell you stuff based upon what you have done in the past. And Sean's vision from the outset has been to enable the individual to be the custodian of their own data. It's not a unique idea. There are lots of companies trying to do this, but the key is always to do it at scale, to do it at a significant enough scale that enough people get involved. You get enough energy to get up into orbit. Basically, this is the whole idea: is just get enough energy to get into orbit, and then you've made it and you can modify and do things over time. But so there are these different component parts, and I'm fascinated, Sean, by this concept of the bridge. As you know, I get it. I understand. You're basically you're trying to build a bridge to the future state, right? This is a giant stepping stone to get into the next generation of computing, and quantum will solve countless of these just annoying little problems. If you look at all the work that we've done over the years, I was talking with someone about this the other day. so many efforts have been put into make up for shortcomings of architecture when you get
100%.
down to it, right? And what this quantum does is it delivers so much capability all at once that there's a whole bunch of nonsense you just don't have to do anymore. All this data movement, and which, guess what happens? When you're moving massive amounts of data around, you are exposing it to being stolen. You're exposing it to problems of truncated fields, data quality problems, all kinds of things. It's also expensive to do this. So, people are figuring out data has gravity. Okay, you see this federated approaches with companies like Starburst and Dremio and Ahana and all these different folks are again trying to look at the steady state, what's happening, how can we sit on top of that and provide additional value? Quantum solves like 80% of these problems out of the box,
100%.
right? But how do you get to it? How do you patch that into your environment? That's what the bridge is all about. So tell us about maybe a bit about Monitor or some of the other companies you're looking to bring in. What are those component parts we need to build?
Yeah, definitely. One of the areas that I think is really exciting is if you look at the telecommunications space in which Monitor has been operating, and you look at moving that to a distributed quantum ledger database. Well, one of the many problems it solves is not only for communication and telecommunications, but it also has the opportunity to change finance. And one of the areas that they've been working on prior to me getting there, and now it's coming full circle, is what happens if you just take all this market data and you start putting on a distributed and decentralized quantum ledger database, and whereby you can quantize and keep secure things that you normally wouldn't see, so that the people who have access to that ability to open that 64-bit encrypted hash can see it dynamically, but the rest of us can't.
Hmm.
What does that begin to look like when you start applying ontological language models against normal RSS feeds on press releases versus moments and movement within the stock? And so being able to provide people a keen understanding on not only the nuanced, but the actual. And so what Monitor's been working on is creating a more efficient and transparent uh, you know uh, capability that can forecast the markets and educate the markets. And that's going
Hmm.
to be, and they're doing their initial work within, just providing some knowledge within the telecommunications sector. So, they're breaking it against the 11 gig sector. So they're first focusing in the telecommunications sector, but then they'll get into energy, real estate, utilities, consumer discretionary, consumer staples, because, when they start reaching back into, that kind of commercial data, what's happening right now, and is there's all these companies that they're called alt data engineers, and like they take all this data,
Right.
from your mobile phone, and they
Right.
forecast the public
Right.
markets. Well,
Right.
what happens when you just make it available up front? I mean, it just makes it a far more efficient model. It helps. Now the market has real metrics. Let's say, okay, this person was within this GICS industry, this industry sector, this industry group, this industry, and this sub industry. Okay, what's their real earnings look like, and how does that compare to the competitors against the total addressable market?
Right.
It just
Wow.
does. Yeah, I mean, now you get deterministic value in the market versus stochastic, and trading volume becomes less important. So there's a lot of really interesting things that Monitor's doing. And then when you flip the side on Newt is a social. They want to create what they call a social 64-bit authentic intelligence, where everybody can upload their own social media data, and all of a sudden people can have a conversation with you, whether it's something you put in X or Facebook, and now families can share it and create a collective intelligence, or influencers can share that. People that are writing books are approaching us now saying, look, I'd like just to have the ability to have a conversation with me as an artist, and then
Yeah.
obviously the
Right.
opportunity to read the book. But just that is going to be more of a social component for authentic intelligence. And both of those are companies that are currently being incubated, along with expanding the node nexus. And then we've got a really exciting announcement coming out of San Marino pretty soon that is my favorite kind of quantum environment that has to do with commodities and the future of custodianship for commodities. That one is by far something that I think is going to have a profound impact when you put commodities in a quantum environment.
Wow. My head is spinning here as I'm thinking about the possibilities, and I'm really starting to appreciate what can be done. And you're right that the markets are a big aspect. We do have a great question from someone in our studio audience. And folks, if you want to be in the studio audience for this show, hop online to dmradio.biz, send me an email, info@dmradio.biz. You can register for these events and those locations, and also insideanalysis.com. One of the attendees writes, well, can't I also become a quantum hacker? The bad guys can get access to this stuff just as well as the good guys. I mean, I guess right now it's probably harder for them because the power is so centralized or is just so rare. But there's no reason to believe that bad guys with an $11 trillion GDP couldn't
Yeah.
get their own quantum engine that they then use to hack into your systems to do whatever they want. But what do you think about that? 3 minutes.
Oh, that's a great question, and so I'll answer that in a number of ways. Number one, when you look at the the pivot to attacking quantum systems is gonna be mildly interesting, but the real focus is gonna be on existing systems. So when I can now apply quantum compute power against an existing web technologies, I'm going to spend it's the path of least resistance. So, when you look at conflict, you can now point a quantum compute capability at your existing firewalls and figure out how to bypass them in seconds. Once you get in, you can apply that quantum computing to run massive analytics in real time of your network segments, identify the endpoints that are most interesting, and then slam that. You think SQL injection is easy on a database? Wait till you hit it with a quantum. So my
Hmm.
first answer is, if I'm a bad guy and I can get a great deal of return on the existing legacy systems, I'm going to focus there. And then once you start getting some kind of density in quantum computing, you're going to see some really interesting battles. You're going to see quantum versus quantum. So what you have to recognize is not only is there going to be that if you look at security, it's much like combat. You got to have engagement areas in which you want to defend. So in combat, you want to focus on your own position, and then after you look at your own position, you look at avenues approach to you. Those would be like network segments and in a network. Then you look from your network segments out to your perimeter. That's kind of like in the military, that's our active effective range. That would be your firewalls and whatnot. And then you go all the way out into the ecosystem fight, the deep fight. So what you'll start seeing is that layered approach. You can take that same layered defense and depth mechanism, kind of mimic Leonidas there with his 300, in which you can literally start implementing, okay, here's my quantum proof mechanism to even access a coalition, because a coalition is quantum proof. So now all of a sudden you access a quantum proof a coalition. Now you're in a coalition of a company's data. So what? All you're seeing is the data that they're willing to share already,
Hmm.
and all the data that they don't want to share has been quantized as well. So now you have first name, middle name, last name, or name of the organization, or whatever else, all quantized as well. So you're going to see this. And by the way, is by the time you're able to even to begin to break the first two layers of defense, when you get down to that last level, the data layer, now you're stuck with another problem. Is you've got all these mechanisms within a data structure that have been quantized additionally, and those and the approaches to those, I won't get into them because they're pretty sensitive, but let's just say there's layer upon layer of abstraction before you even get there, making
Right.
your ability to hack that. I jokingly say, you can kind of give in the future with this approach, you'll be able to give the bad guys the IP address and a prime finger at the same time. It's
All
it's
right, folks, we'll be right back for the podcast bonus episode. You're listening to DM Radio. All right, folks, back here on DM Radio, another fantastic episode. We're talking all about building a bridge to quantum computing. I love this concept. We've got Sean Michael Brehm from CrowdPoint and Node Nexus Network. Now he's the chairman of Spectral Capital, which is investing. It's looking for quantum companies to invest in. We've heard about Monitor and Newt is the other one. They're looking at other component parts. And again, I'll just go back to this analogy of a new engine for a car. I love my car. I've got a 2001 Mazda Miata 6 speed. It's so much fun. It's very powerful for its size, and that's what makes it fun. But imagine taking a rocket engine and sticking that in the car. Well, you don't want to kill yourself on the first drive. You have to get new batteries, you have to get new tires, new brakes. Like you basically have to rebuild the chassis in order to leverage this engine. So what does that look like? Well, these folks, Sean already has multiple of these component parts. A quantum ledger database, I think, is the foundation because it can take input from these quantum systems and then do various things with it. And you can connect all your traditional applications to that. Because let's face it, we don't want to have to rip and replace everything. This is one of the biggest challenges in computing is that you always have all this legacy architecture that can't easily be disposed of. Now, there will be net new companies that come along and will be vastly more efficient by using these technologies. So that's going to be interesting to watch. But what kind of triggered my thought process here when you were talking is thinking about the stock market and thinking about alternative data and thinking about getting a feed. I remember writing about this a few years ago. I think you've even read this article where I talked about outsider trading, which is basically where entities on the outside get access to so much real world data, transactional data from credit card companies, from mobile phones, from all sorts of different sources, and can thus ascertain whether or not a company is going to meet or beat market estimates. Well, one thing that's going to happen is that these quarterly reports and quiet periods I think, are going to go away eventually because there's going to be so much data available. But it's like, how do you help the common man? Is it just going to be Goldman Sachs and these other big institutes that have the wealth and the power to leverage this stuff, or will we have an antidote to that? And I kind of think that's what CrowdPoint is doing, and what you're doing with the network is you are providing a counterbalance to all of that insider outsider trading, if you will. In other words, there are these groups of people who have tremendous wealth and power, and they have all the data. They have a tremendous amount of data, and the more power they get that we don't get, the more disadvantage there's going to be for us from that relationship. So maybe just finish off on that, Sean. You are providing an equalizing agent here, a capacity for the common man to bond together in a coalition through the Node Nexus network or CrowdPoint or through the Spectral Capital to be able to offset and compete with that whole environment. What do you think?
Yeah, I mean, that's really been my passion from day one. I mean, using our oil analogy, we know that information is the fuel that powers the global markets. We know that information or fuel needs a raw material, and that's oil, and oil is data. But when you think about oil comes from life. And in this case, it's the human life. And so when you think about the human life, most of us operate within the commercial markets. But what you're seeing is commercial markets dictate capital markets. Your purchases matter. And
Hmm.
so when people start understanding that this global economy, they are in fact the progenitor of it, whether you're in Botswana or you're in Utah, it makes no difference. You're swiping that card each day, you slapping down euros or dollars. Every time you make a purchase, that purchase is literally the commercial markets. And then people take your data and they sell it all day long to these people in the markets that can forecast where the market is going.
Right.
And then they put it in databases which other people want to steal because it has value. So you are the most important cog in the wheel. So what happens is when you start seeing systems emerge, and I'm seeing them, I'm meeting with a very big CEO of a very big bank here in Switzerland tomorrow, which is looking at taking every swipe of the card, taking that, making sure your identity is completely covered, your location is completely secure. We maybe show a zip code which you're in so you can start creating value to the outside person, and then everything else is transparent.
Right.
Now all of a sudden you index that against the global industrial categorization standard, the very same standards that we organize public companies. You now have this measuring stick of what's happening in the commercial markets and how it feeds the capital markets. And if you look at those in just simple math terms, you've got, an intersection and union, and that union is you. And so
Wow.
this is a tremendous opportunity to provide individual value back to you, the one that
Hmm.
drives this, whether you're in Botswana or Utah, and
Right.
and what the impact that has. when all of a sudden your data is custodial, you are the custodianship for it. People are going to come and say, what's the interface that I can talk to this guy in Utah to buy a new car? Well,
Mhm.
you can't ever know who they are, but we can give you the ability through an interface that you advertise to them, or you want to buy a certain stock, or you want to sell a certain stock. Quantum computing is a kind of reset that I think is much better than the other great resets that have been put out there. It's a really unique opportunity. And when you understand the impact that has from, new kinds of Sharp ratios and enhanced financial alphas that can be derived from there, it solves so many of our tax issues. It solves so many of our market issues. When you
Right,
put value back to the progenitor of it and allow
right.
them to participate in that value, it just brings nothing but good.
Yeah, this is a truly pivotal moment, and I get it, I understand, because, again, the power of quantum can solve so many problems so quickly that right now we are using tremendous energy to have workarounds to solve. And just even think about supply chain. Think about a manufacturing company that wants to build something. The complexity of knowing how to get all those parts into this location at a certain time, knowing what price to pay for them, all that stuff is very difficult and very challenging, and
But
can
what
be a
happens to
significantly
your web experience? What happens to companies like a Google when you no longer have to go to a Google web page? You're merely asking a question of what you're interested in, or you built your own, and all of a sudden you're getting notifications based upon spatial, temporal, and thematic scenes.
right.
Scenes. It's going to redefine our user experiences.
Wow. This is great stuff. Well, look this gentleman up online, folks. Look up spectralcapital.com, just like it sounds, Spectral capital, al.com, or Node Nexus Network or CrowdPoint Technologies. Send me an email, info@dmradio.biz. You have been listening to DM Radio.